So welcome back everyone. This is part 2 of our classification tutorial. Yesterday we were working through this section 1 classification under lab 4 of environmental monitoring and modeling. And we got to the point where we had created a quick classification over Darwin Harbour, very broad classification separating land and water, and some infrastructure in the city, but we had quite a few problems with water appearing in any of the dark features within the city. So we're going to now look at improving these classifications, and one of the ways to do that is through using a time series of imagery, and of course by collecting more training data. Also, if we come over here to the docs panel, you'll see in the script that we've been using that we made use of the Earth Engine classifier cart. And if you come in the doc section, we can see EE classifier. If you open that, you'll see that there are in fact a lot of different classification options within Google's Earth Engine. Some very advanced machine learning techniques, and some really great options, including random forests and support vector machines. So the one we've been using so far, CART, is stands for Classification and Regression Trees. First developed back in 1984. Here's the reference for it. A lot of different options. We can go deeper into this, but what I'd like to do for today is just work with modifying our existing script to include a few more classes and perhaps using a new area of interest. So let's go somewhere quite different to the tropics. Let's now go down to Alice Springs, Northern Territory, Australia. Here it is. Let's switch to a map view. Zoom out a bit, and let's delete our ROI as well as these geometry imports that we've created. And we're going to make a new ROI in a different area of interest. The area I'm looking for is the iconic Uluru. So let's go to the satellite view, have a look at this landscape. Some really beautiful terrain features. Go back to the map to navigate. Uluru is just at the point of this Highway 4. So this is it over here. Very nice high resolution image as the Google background map. Let's just delete that. We should now have no geometries. So we can click on the teardrop icon to create a new one. And we'll place a pin on Uluru, and let's rename that ROI. Now, what we're going to do is that, remember, our first part of our script was filtering an image collection. So, and then from then on we went into collecting the training data. So first, to look for the image, let's comment out the rest of our code, and we do that by using the command /key, which turns all of this code to comment lines, meaning it won't be running. Now if we run our script, we will find that, zoom out a bit, go back to the map view, we'll see that the filtering part of our script has worked. We've still searched for an image in 2015. We've done a sort by percentage cloud cover, and we've asked to return the first image. This would be the most cloud-free image in that date. So it looks very red center of Australia, not much vegetation and no real infrastructure. But if we zoom out a bit, we can see quite a lot of variation in the scene. So let's start building some classes. We're going to do this the same way as we did it yesterday. We'll add a new layer. This will be called geometry. We click on the gear wheel, and we'll rename this. Let's just have a look at our scene again. What are we going to classify? We have these rocks, bare rocks over here. We have some lighter red soils, some darker red soils, and some water bodies. So let's focus on these. Click the gear. We'll call this red soil. Note that I put an underscore for red soil. If I were to just have a space, it wouldn't let me name it that way. We're going to import this as a feature collection, and it's going to be, property is going to be land cover with a value of 0. Okay, now let's collect some red soil features. Zoom in a bit closer, and let's try and get them spread across the scene. So let's go for 10. So we have 6 so far. We add another 4 distributed throughout the scene. Now we have 10. That's great. Let's do the bare rock class first. Next, add a new layer. I'm going to rename it to bare rock. Feature collection. Add a property, land cover, a value of 1. Okay. Remember that these values we're adding are just so that we can identify these classes within an attribute table. Let's click a few more points where we can see that there's bare rock. Remembering that the point of this is to collect training data to train the image classifier. And one more there. Great. Let's add a new layer. It doesn't matter, I've done 11 now. It doesn't actually matter the numbers that you have. You just don't want one class to be disproportionately larger in terms of attributes than another. So our next class, let's make this the dark soil. Import as a feature collection. Add the property, land cover. We've used 0 and 1 already, so now we use 2. Okay. Just zoom out a bit to get an overview, and we can start adding dark soil patches here. There we go. And the last class we wanted to look at was right up in the top of the scene. You can see these different water bodies So let's make a new layer, rename that water, feature collection, add property, land cover, and this is going to have a value of 3 since we've used 0, 1 and 2 already. Okay, let's collect 10 of these. Be sure to cover the bare pans as well as ones with water in them. There we go. Now we can exit the point drawing mode and let's look at the rest of the code that we had so far. The next step was to merge feature collections, creating the variable new feature collection, urban merge with water, merge with vegetation. Okay, but now we've changed our the names of our features, so we need to update that. And also remember, we've commented out these lines so that they don't run. We just push command or control / that will uncomment the code part and allow the script to run. So let's change urban to red soil. That was our first class. We want to merge that with bare ground, and we want to merge these with dark soil, and we need to add another merge because we now have 4 classes instead of 3. So we put dot merge. Our last class was called water. Let's run that. Oh no, background is not defined in the scope. We'll go back to our geometry imports. We called it was bare rock and not bare ground. So let's just change that to bare rock. Luckily in the console, when we have an error, it tells us which line the error can be found in, allows us to fix it. Let's run that, and it should work fine this time. It does. It shows us we have 41 elements in our new feature collection. That's 41 because we have 4 classes, 10 per class. One of them I had 11 in just by mistake. Now, the next step was to create training data. Let's uncomment these lines using command / fix that little spelling mistake while we're here. Remember, we're going to sample through the variable bands, and we're going to use bands 2, 3, 4, 5, 6, and 7. For training, we're going to select from these bands our sample regions, which are defined by our land cover classes within our new feature collection. And we're going to print that out as training. Let's run that. Here it is. And if we look down these features, look into detail for one of them at the properties, we'll see that there's 7 properties. There's the reflectance value for each band and the cover class that we have attributed to it. The next step is to train the classifier and run the classification, so we can uncomment all of that, because all of this will now just work as it did in our previous script. That's the real beauty of using scripts. So once you have a nice script laid out, you only have to change a few attributes for the rest of it to work in a new area. Let's run that. The classification has run, and the last thing we need to do now is uncomment this section to display the classification. Now let's be a little bit careful here, because this min and max relates to our land cover classes, In the previous example we only had 3, so that's why min can be 0 and max can be 2. Now that we have 4 and we're starting at 0, we need this to be a 3. And let's choose a good color palette for these classes. Red soil, let's go back to our website here, htmlcolorcodes.com. The red soil, well, let's make it red. So choose a shade of red that you like, copy the code, and paste it here. So the palettes work just by giving the first color in order down the list. So because we merged red soil first, then bare rock, then dark soil, then water, we go in that order. So next up is bare rock. We'll make that a gray, maybe a light gray color. Copy the code, paste it there. Then next up was dark soil. I've got a red, and we could go with a brown. Let's go with kind of a dark yellow, just so that it remains well. Let's go slightly lighter color even though it's dark, just so that we can see the difference. Copy that, paste it in, and now we need to add one more color because we have 4 classes. So we'll just add that to the end of this line, and the remaining class is water. Let's choose a nice light blue for that. Paste there, and let's run that classification. Zoom out to get an overview, and we can switch off all these geometry imports. Zoom in a bit closer. And here's our classification. If we come on the layers tab, this layer 4, just these dots, that shows us where our training data were collected. So this has done quite a nice job. If we flick off the classification, we can see these different patterns. Picked up the bare rock sections nicely, picked up the water bodies. There might be a bit of confusion between the red and the darker soils, but all in all, quite a quick process for achieving a fast classification. Of course, what's missing from this is a validation and an accuracy assessment. We do have options within these classifier tools for conducting not only training but also validation and building appropriate accuracy statistics, but we'll save that for another tutorial. So before we end this tutorial, I mentioned earlier that one thing we need to be careful of in the classification is, of course, the time of year that the image was taken. If we can build a composite over a few months, we have a better chance of achieving a good classification. But also be aware that we've filtered this image by cloud cover in a year, and if we have a look at that image, it's very dry, collected in the middle of the dry season. So one thing you could try is if we were to just change these dates to another year. Let's see, in 2016, that's the beauty of the coding environment. If we want a new image, all we do is change these dates, and this code will now run across another year. And bring up a new image. So is the desert, and our date range still returns an image from the dry season, but we've used those same training data. A few differences we can see now is that we've picked up some water in the bare rock. If we zoom in a bit closer, we can see, what we can see here is that although there are some rivers in there, what we're probably picking up here are these shadows on the southern side of the hills. So we would need to be careful of that. A good option for that would be to pull in the SRTM data that we've worked with previously and add some terrain attributes to the classification. Let's just try and narrow our search to a summer month. So if we bring that forward to, let's say, October and run the script, we now get quite a different result. Let's have a look at that. So the point I just wanted to make here is that if we train a classifier on one image, that's not necessarily going to work through time. So ideally what we should be doing is using the time series data in our classifications. And in a few other examples this week, we've looked at making image composites by obtaining the best pixel through the course of a year, for example, and that would be a good approach for improving the reliability of our classification. So, thank you. Good luck with the rest of the course.